Morning, ladies and gentlemen, honored guests, faculty. Our project is an application-specific integrated circuit encoder with an integrated lookup ROM table. My name is Akinola. Members of the team are Gian, Swati, and we have Professor Hu as our advisor. Project was also sponsored by IBM. What we observed is that there was a rise in the portable electronics market with devices such as ultra-mobile PCs, mobile phones, and ultra-slim MP3 players. We asked ourselves why this rise. With the advances in silicon integrated circuit technology, every year these devices became smaller, faster, more efficient, and larger. Well, the demand for these devices also increased because of the fact that they were cheaper as well. What we wanted to do was tap into this market, develop a chip or a chipset using ASIC for the ultra-mobile electronics market. What we designed is a Huffman encoding device that will develop a chip to compress more probable 6-bit sequence into a smaller code word, as shown in the highlighted area here. This is done via Huffman coding. We created an ASIC design that will take the 6 bits, use the lookup table in ROM, and assign the appropriate Huffman code words. Our product is of special interest to developers who want to design lossless data compression techniques as seen in media files such as JPEG, MP3 files, and zip files as well.
In certain applications, ASICs can eliminate the need for a microprocessor, thus reducing the cost. Our design of the ASIC has a very small footprint due to the number of transistors. This low number of transistors translates to a longer battery life. Also, some processes can be offloaded from the microprocessor to the ASIC, thus improving the overall performance of the system. One of the common approaches to develop the ASIC would be to write the VHDL code and automate the physical design. Another common approach would be to write the software for the microprocessor that would perform the encoding and decoding of the MP3 file. Our approach, on the other hand, was completely custom. We did not use pre-existing libraries. We, in fact, used custom digital logic, and hence, overall, there was no automation whatsoever. For the design flow, first, we designed the logic by hand. Next, after the design was proven to be correct, we created a schematic in the design architect. After that, we simulated it in AccuSim, and once that was proven to be correct, we laid it out in the IC station. This is the final design of our Huffman encoder as seen in the design architect. Once the design was proven to be correct, and we simulated it in AccuSim, we laid it out in IC station, and this is how it looks in the IC station.
So obviously, this is a very big project. In order to break this down to easier steps, we employed a cell-based design that pretty much we laid out the most basic components and routed them to develop the larger cells. So overall, we were very successful in this project. We gave the chip 6-bit inputs, and the product returned back the specified Huffman code words. The final specs of the chip is, well, the transistor widths of the chip was optimized for 75 megahertz clock speed. Also, we used a 0.35 micron technology. That's the TSMC035. The chip is made up of 3,336 transistors. That's both PMOS and NMOS. Also, the chip is relatively small at 0.457 millimeters squared. Finally, we were able to do this chip in only 4 metal layers. So, as of now, the chip has both logic and ROM on the same on the same die. What we can do in the future is separate them to add versatility and options to the developers. This will allow developers to change the lookup table for different encoding and decoding tasks. Also, this will allow the developers to update the old lookup table but with a new one just by swapping the old ROM out and putting in a new one. Also, we can make this encoder a different type of decoder completely by changing the lookup table to a parity bit encoder or decoder, so it has some flexibility and also attracts digital communication developers. Finally, since we developed part of the Huffman coding, which is part of the MP3 algorithm, we can add to this chipset and easily develop a complete MP3 chip. So what we learned a lot of digital logic. We used various counters and shift registers. We also implemented different ROM designs and experimented with a couple. We also learned VLSI design and tools such as Mentor Graphics and HSpice. For achievements, we created a chip ready for fabrication. We can send this to a fab somewhere. We can send the plant to a fab somewhere and get back a product within a couple of weeks or so. Also, we developed an ASIC that utilizes a low-power design. We used only static logic and no dynamic whatsoever. These are our references. We'd like to thank Professor Hu and our IBM mentors, Kevin, Powell, Anthony, and Rudy. And we'll take any of your questions.